Bismillah ar-Rahman ar-Rahim. Welcome back to our lecture on learning methods in machine learning. We started in the previous lecture talking about learning methods, and we'll continue in this part, which is part 2 and the last part about the same topic. As if you remember or you pass by the lecture video, you'll find that we describe or classify the learning methods in machine learning into supervised, unsupervised, semi-supervised, and reinforcement supervised learning methods. We talked about the supervised and the unsupervised. In the supervised machine learning, we define the type of the supervision. We can do this in regression and in classification tasks where the input data set is labeled. All elements or components, let's see, or samples in the data set are labeled, and we know the inputs. This is why we call it as a supervision, because the output is already known for each input, and we try to track and find the parameters of the network that we want to train in order to modify and update these parameters and to use this network in future work for another data that is already known data and new data and is not labeled actually. In the unsupervised method, the same operation can be done while here with the data which is available in the dataset is not given, is not labeled, it's unlabeled data, and we usually use in this case this type of machine learning when we have complexity or difficulties in labeling the input data. We have different techniques and methods to use it based on the unsupervised machine learning method. And this was the last part of the last part, the end of the part 1 or the previous part. We'll now continue to the other two types of machine learning, let's say, methods, the semi-supervised and reinforcement learning methods. Let's go and see the first type, which is the semi-supervised learning method. Here in this type of deep learning, machine learning, we are going to use a supervised technique, but not totally, but it's partially. So we call it as semi-supervised. Why? Because we have a part of the data is already labeled and the other part is not labeled. This is the name idea behind using the semi-supervised learning, or the SSL in short. So SSL is an ML algorithm that works between the SL and USL, between the supervised and the unsupervised learning method. The approach is useful when the data is expensive. It looks like in the case of the unsupervised, and it's time consuming. So you need a lot of time to label the data, or maybe it's not easy to provide labeling to the data because of the difficulty to approach or to get a lot of details about the data itself, or not easy to let's say classify it in advance. Now in the semi-supervised technique, the idea is to choose between two options. The first one is when the data is easy to be labeled, you can apply labeling, and you can use this labeled data in order to continue the learning method by using unsupervised part, which means that you need to get the required skills and abilities to apply or to continue, let's say, classifications or the other tasks by using the partially labeled data set in defining, let's say, the situation for the other unlabeled data or the samples in the data set. Okay. Now we can use the method for the unsupervised case by feeding the unsupervised, let's say, the technique into the supervised technique. This can be done, of course, in many applications where we can't label every image. For example, sometimes the dataset may contain, let's say, 2 million, 10 million images, and it would be a very big hassle to get all the images in the dataset being labeled. So we are here repeating the same idea. By using the semi-supervised learning, we can partially apply labeling to the input data and partially skip it, which means that we can apply now by feeding the unsupervised part of the or the unlabeled data uh, into the supervised techniques, and in this case we can get the classification or the regression, whatever the application to get the to approach our task. Let's have a look on this demo. Here we have the input data as you see here. This data is actually contains part of the input data is in the dataset is labeled, partially labeled. As see here, we have this is the input data, and this part of the data is labeled like the camel, the and cow. And this another part for the elephant, for example, is unlabeled. So we can feed this data set into the machine learning model, where it can use the labeled data or the supervised part in order to aid the unsupervised part of the algorithm and get a prediction at the output, which is in this case an elephant. And this will give us an idea about what we can do. It means that we don't have from the beginning, we don't know what is animal to be. And by using the label data here, we can recognize or we can distinguish and define the type of data which is unlabeled. It's a good idea to have some information about the semi-supervised. In general, in image classification and object recognition, it is very strongly recommended or used when we have very large data sets. Again, the same thing as in the supervised and the unsupervised. It can be used for natural language processing, for speech recognition, for recommendation systems. All these applications can be found all over the world in all classes and in all aspects of our life, scientific, social, etc. And this is the main idea of the machine learning. It invades actually all aspects of our lives. Let's have a simplified example on this topic. Suppose that you are going to build a language translator or translation model. Having label translations for every sentence is not easy for sure. So you cannot label every sentence pair in any language in the world. However, you can do this partially by applying the labeling to a part of the sentence pairs, maybe 10%, 20%, making them accurate and available for the algorithm to be applied next on the semi-supervised learning approach. This actually has been implemented in language translation and has a very significant improvement in the quality of machine translation services. This can be seen when you have automated language translation, or in sometimes when you translate from speech to text or from text to speech. All these things can be also used very effectively. What are the methods in semi-supervised learning? We have many techniques. This includes graph-based semi-supervised learning. Here, we use graphs to represent the relationships between the data points. And actually, this gives you a possibility for better visualization of the connection between these, let's say, using these relationships. This graph is then used to propagate labels from labeled data points to the unlabeled data points. Also, label propagation. This approach can be used iteratively to propagate labels from the labeled data to the unlabeled data points based on the similarities or the links and the relationships between these data points. We call also another technique, or third one, which is co-training. In this case, the approach is based on using or training two different machine learning models on different subsets of unlabeled data. So you take two models, then you get the results and use to label each other you would use one to label the other one and vice versa. And this can be a sort of co-training in by dividing the large dataset into smaller datasets maybe and apply such approach. We have also something which is called self-training. In this approach, the training can be done on the label data and then use the label data to predict labels for unlabeled data. Again, we are repeating the same ideas, but the approach is different in how to apply this tool to the semi-supervised learning method. It can be also extended to very interesting and exciting application, which is called the generative adversarial neural networks, GANs. Here you can produce fake or synthetic data from the original, let's say, actual or real data. For example, you may have sometimes a data set having a low number of components or members or elements, and you are not able to get more data samples to produce a good data set for your next step for training. Now you can apply this data set to the GAN, where you can produce new images, new samples, new data points that can be extracted or generated from the already existing data points or let's say images or whatever else. And in this case, you enrich, you enlarge the size of your data set by applying something like it looks like a fake thing because you don't have this in your original data set by producing or repeating or it's a sort of we call it augmentation. You augment the data set by applying different techniques. One of them is the implementation of the GANs approach. And this, of course, requires two training neural networks. One is called the generator, and the other one is called the discriminator. Sometimes you can produce using this type of semi-supervised learning that you can produce fake images, fake videos by generating a video from another one. For example, this is my video at the top, my image at the top of this file, as you hear, of this screen. You can replace my face and keep me talking, but in maybe in another language or regarding another topic. This can be done using the generative adversarial neural networks, and this is a part of the let's say supervised learning, and it requires, as I just said, it requires mainly two parts of neural networks. The first one is the generator and the discriminator. We'll have a look at this maybe in the next a few lectures as I remember when I prepared this course. As you see here, we have a semi-supervised learning use case. You see here we have a small amount of data which is labeled. You see that we have red and blue colors. It looks like it has a label of red and a label of blue. And the large amount of data is unlabeled. We don't know whether it is blue or, let's say, red. We apply this to our training system, our machine learning model that tries to get the output data to be pseudo-labeled data set. And then we can train the model using the pseudo data label, this data processed by the first ML machine or model to continue our work as a more or less supervised learning approach. And this is one of the good examples on how to implement the SSL approach in classification, for example, or in other approaches also. Here is an example. We have the labeled data here, and here we have the unlabeled data. Let's talk about this. Okay, this is the part where we have the labeled data. Here we have the unlabeled data because we have either triangle or circle with other data in as small, let's say, green circles. This data is unlabeled. This data is unlabeled. We don't know what exactly the label of these points. Next step is to provide supervised learning by dividing this into two classes. This is the circles, and these are the what we call the let's say the triangles, red triangles. Now we can apply this approach further to further split these images or these samples. It could be image or it could be voice, could be anything else, into two classes. Where we have here, we use the supervised part to get the unsupervised classification or clustering of the input data according to its implementation. I think it's more or less very well clear, and let's go further and see what we can also talk about this. What are the algorithms? We can, as we have just mentioned, graph-based SSL, label propagation, SSL, co-training SSL, self-training SSL, and generative adversarial networks or GANs SSL. Here you can find the links regarding these this topic or these algorithms in the SSL approach. The last part or the last class of the machine learning methods for training or for learning is the reinforcement learning, what we call it in short RL. Now, RL is a learning method that interacts with the environment by producing actions and discovering errors. So this is very related to the programming of robots and to robotic programs. What we need to know here is that it is based, this approach is based on the interaction with the environment and by producing actions according to whether we have a fault or error or to stop, or we have a correct answer to get a reward. So the main idea is to trial and error, to apply different trials and learn from errors. And these are the most relevant characteristics of this type of approach of learning. So in this type of applications or learning methods, the model keeps on increasing its performance using reward feedback to learn the behavior or pattern. What does that mean? That as the model is used more and more, it will be updating its performance by learning from errors and getting push by having a reward that with a feedback, of course, that you have a correct output, so you can take a reward and continue in this direction. This is the main idea behind the reinforcement learning approach. In fact, the techniques used here are a little bit different from the previous three types, the prescribed three types of learning, which are these supervised, unsupervised, and semi-supervised learning, because it has a different target. However, you can use it according to your application in many aspects, including the aspects of the other types of learning methods. Another point here is that these learning techniques are specific to a particular problem. So they are problem-based approaches, and they are not in general to be applied for general purposes. And now you can find this in applications like Google Self-Driving, AlphaGo, where a bot competes with human and even itself to get better and better performance in Go game. It's an application from Google, and you can deal with a bot that it can compete with humans, and it can improve its performance by playing more and more to get increasing or to get improving the performance of itself. So each time when you feed in data, they learn and add the data to their knowledge. So it's a type, or it looks like as a small child that learns more and more by when he grows up. By stacking or by memorizing all the previous errors, previous rewards in memory, in his memory, I mean the child, he learns more and more and become knowledgeable person as he's growing up. The similar topic is, or the similar approach is done in the case of reinforcement learning, where you can learn from the computer or the robot can learn from its errors, and it can get benefit from the rewards when getting a good and an output which is fair, and this gives it a sort of experience and improves its wisdom and knowledge about the topic that is dealing with. Examples on the RL. Suppose that you are training an AI agent to play a game like chess. Now the agent explores different moves and receives positive or negative feedback according to his play. So when the robot is playing, you learn the robot how to move the chess let's say stones on your chessboard. Now, when you play against the robot, you'll get some errors, or the robot will get some errors and will be defeated. Day by day, it will learn from the errors and build his own or its own, let's say, procedures to improve its performance. And it learns from errors and takes feedback when you have a good feedback or a reward, and this improves its work. So if we look at this scale, now we have what you call it, the agent, here the robot. Here we have the environment where we play the chess game, and here are the actions in this game. Now, if you get some error action, you can get feedback, as here we have reward. Okay, it's working very well. You can continue further. Here, if you have a bad action, maybe you can get and change, or you can get a feedback that comes back here and corrects the operation or the its work. So you can learn from errors and from rewards in a feedback process to improve the performance of the robot or of the software or program that you are designing or implementing. Again, you can say that it's clear that from this example that the device or robot or maybe machine learning algorithm will perform some task by interacting with their surroundings or surrounding environment, and this is fair because you learn from the as a human or as a robot from the surrounding environment or from your surroundings, neighbors, and actions, or what you get from the environment surrounding you. Now, we have seen three types mainly of machine learning: supervised and supervised, and supervised and the reinforcement learning. In the first one, whether it is supervised or unsupervised, you can predict next value, task driven, it is driven by the task, while in the unsupervised, it's data driven. So you have to identify clusters according to what you have get from the unlabeled data, and you can bridge the both parts in one task or one function by using the semi-supervised learning method. In the reinforcement learning, you learn from mistakes, so you get reward. So it's positive. Okay, continue further. If you have some error, you have to correct your action, and this means that you learn from mistakes. This is similar to this game. If you remember it, when we were maybe 10 years ago or maybe more, we played this Batman game, and it's one of the good applications on the supervised on the reinforcement learning approaches that can be used, and the chessboard games that were also familiar at that time. This is mainly as a recap or comparison between the supervised and the reinforcement learning and the other types of learning methods. This is a duplication. So we have here the input, as you see. This input raw data, Apple or not. So you don't know exactly what is it. If it's okay, Apple, model training, you go to the agent, you perform the operation, you check, you get an output. then you can to use the environment and get feedback as a reward, either it's a mistake or it's a correct. And now the operation will be corrected if it is an error, and you learn from your mistakes to model the system. Finally, after the model being prepared, you can apply a new input here and ask whether it is an apple or not. And the trained model here, after modeling stage or after training stage, you can find the features according to what you have learned as a robot during the training process, and you can now define and say, okay, yeah, it's an apple for sure. Here are different types of approaches in for supervised, unsupervised, and the reinforcement learning. Here in the supervised learning, you are using a loss function. It's just a sort of recap. So you apply the features and the labels to the supervised learning. You can use the loss, and by correcting or reducing this loss, you can get the prediction. In the unsupervised learning, the method is that you apply the features, and you may use some unlabeled data to find hidden patterns in the system and get your output patterns in this data. So the objective of the unsupervised is to unhide, uncover the hidden relationships and let's say links between the data points. This includes any type of data point. Now, in the reinforcement learning, you have different actions and states, and you apply to the reinforcement learning. And by taking feedback as a rewards whether it's okay or not, you can get best action at the output by correcting and improving your knowledge day by day and during the time that you are working on this model. I think it's more or less very clear from these slides what is the main idea behind using or inventing the reinforcement learning. It has a lot of applications actually in the field of robotics and its applications. What are the types of uh, reinforcement learning? We have model-based, like Markov decision process, Bellman equation, Monte Carlo tree search. We have model-free methods, value-based methods, policy-based method, actor-critic method. So in these cases, we have in the model-based, we are building your system based on a specific model. Here, the model is not given, and you try to build your own system. The applications is a long list of applications, mainly gaming, for gaming theory and gaming applications, in robotics, autonomous vehicles, in healthcare, finance and training and trading, energy management, game AI when you play with games, or when you um, uh, apply gaming or action in robots. Also in industrial control in different topics like the control of quality, control of the operation of the mechanical parts of the industry, etc. All these things can be done using reinforcement learning. Examples on algorithms that can be used for RL learning. Here we have the Q learning, the what we call it SARSA learning, deep Q learning, and other types can be also found in literature. This is a good animation for you if now you play a game. So if you remember Mario, and according to the reward and the state and the reward, S1 and S2, you can correct your action on the next stage or the next state. So at A0, you get reward S1 and R1, reward and state 2 and reward 2 for A2, etc. And you continue this loop. And every time you play the game, the robot will be learning more and more and improve its performance with time. There's another game also based on Markov decision process when these cubes are playing football. And this is a method of implementing gaming using Markov decision process. This is related to the Google's AI learning to get around the obstacles drunk bots. We call it, it's called the drunk bots. You can search the drunk bots on Google and find how it is designed and how it's the general block diagram of its operation. And as you see that you can learn from according to the height of the obstacle, the robot or this is not always reaching from the first time the top of the obstacle, and it learns from errors from the feedback to continue and jump all over all these obstacles. Uh, this is a good link that you can find a lot of things. It's from Geeks for Geeks. The title or the name is not very uh, doesn't look very nice, but you can find a lot of details that can be helpful for you in following these ideas or these topics in the field of image processing and machine learning and deep learning. Well, that's all talks for today. Hope that it was enjoyable for you, and wondering if if you have any questions, you can send it to me on the course MS Teams. And now I think it's time to go, and see you soon.